Okay, so we got our surface again. You can see that it's there's a lot of kind of clipping of material. So I'm just going to select the surface in Rhino and type hide. And now I just have my highlighted green. So the first thing we're going to do to this, we're just going to kind of incrementally build onto the script. So the first thing that we're going to do is, like most site models, find our contour lines.
Sorry, can you back up? What's the first box you have in Grasshopper?
This one, so this is our surface component. So again, remember, whatever you create in Rhino, whether it's a point, curve, or surface, you're going to use that same type of component to reference it. So we go to, so you go to parameters, geometry, and use the surface component. So just remember, every time you bring something in the Grasshopper, you start off in this first tab. So now we're going to find our contour lines. It's kind of in a weird spot. It's on like separate area. So I'm just going to double click this screen and type contour. And there's a couple different contouring that you can do in this. Make sure to select this one where you have this rectangle with this kind of arrow. It says create a set of B-rep or mesh contours. So select that one. You should have it just saying contour with these 4 inputs. I'm going to drag the surface into this first one where it says shape. The next component is asking for a point or a start point. That really doesn't matter a whole lot in Grasshopper, but these next two are a bit important. So again, direction, that's good. We want it to go in the Z direction. And then we need distance.
What kind of code?
So it should look like this rectangle with this arrow. So if you really want to find it, you can go to intersect, physical, I think. Nope. Mathematical C, like I said, it's kind of a weird one. And it's this one. And so the next thing we just need to know is distance. So this kind of gives you a lot of control on knowing if you want to do 1 foot contours, 5 foot, 10 foot. You have a lot of control over that. So I'm just going to double click my canvas here again, type 10, just because it's easier to start off with a high value. And if I want there to be less or more, I can always drag it. So 10 foot contours doesn't show me a whole lot of detail. So I can just take that slider and drag it, and there's probably going to be a little bit of lag, but you'll see that it's doing its best. So I could probably get away with 1 foot to show enough information. Okay. So there you go. Now you have your contours for your surface. Something that's good about this is that it's pretty easy to even do when it comes to fabrication. You can actually change the direction for your contours. So if you want to slice it vertically, all you have to do is change the direction. So if I want to do it in either the X or the Z direction, I can just type Y, and I probably don't want these to be 1 foot. I can do 5 and select Y. And it's a good way to kind of get your section cuts made.
So if you baked those lines in, and you could just sort of separate them.
Exactly.
And you would have as many section cuts as you.
So we can give this surface a volume. So we can decide like how much of a base do we want, and then we can simply slice it in either direction. So I can add both y and an x. If I want to look at both directions, I can hold shift to get a plus sign. This will take a second because now it's looking at the contours in both directions. Now you can see it's really just creating a grid. And so then you can even create a waffled model. So just realize you have that kind of control as to what direction you want these contours to go. It's good for fabrication. It's good for doing section cuts. Obviously, you can just always change the distance depending on how frequent you want those section cuts to be made. So although it's not a whole lot in terms of its complexity, gives you a lot of options.
And that's a really easy script because it's just a slider, you link the surface, and then there's the contour.
Exactly. Okay, so the next one we're going to add to is from our plugin, we're going to use that mosquito one to do our drainage lines. So go over to your mosquito tab, choose the vector one, and choose the flow one. So this one where you can kind of see these different arrows going. And this is good to kind of check with, because then if you can start to identify where your swales are in the surface, you can see if the flow script is actually running it correctly. Are those flow lines actually following the swales, or is there some discrepancy between those? So they do a pretty good job when these plugins get made. So you can easily see, okay, I need a surface. So that's our surface. The next one, you have a lot of kind of freedom to do. It's asking for points to serve as the starting point for your flow lines. So you could kind of prescribe like, okay, I can see that here's the top of my site, so maybe I want to start up there and have some lines or flow lines drain, or I could treat it kind of like a rain scenario or a rain event where I imagine water dropping on a grid of points and seeing how each one of those responds as well. I generally prefer that method more because that gives a more kind of realistic outcome. So in order to do that, we're going to do something like we did before, where we're going to take our surface and divide it into a series of points. So again, we're analyzing our surface. So we go to our surface tab, and then we're going to choose utility and divide surface. So this is what we had done earlier, where we took that flat surface and divided it into a bunch of points. So again, it's asking for a surface. So there's, again, a default of 10 by 10. And this is, again, kind of up to you on how much information you want there to be, where you play with the density of your points or grids.
So these are our raindrops.
Yeah, so think of these as, your raindrops or the start of your flow lines. So you can show, like, if you really want to see the intricacy of the detail of it, you can really make it dense. Or if you just want to get its general flow dynamics, you can keep it fairly broad or vague. So it looks like, let's just keep it even and say 20. Okay, so I got my points. Again, like, this branches out that data, so I'm just going to flatten it. So I'm going to right click on my points output and say flatten. It doesn't really do anything in terms of visually, but the data organization is important. So
would you say it's a good rule of thumb that anytime you create points like that, you flatten them for what we're going to be doing?
For what we're going to be doing, yes. There's definitely circumstances where you don't. I can't think off the top of my head, but there's been multiple times where I've had to keep it like that. So.
But at our level that we're working at, you can
Yeah.
sort of think of it in your head that anytime you use
Yeah.
that S divide to make points,
Yeah,
but the next thing that you have to do is
flatten them.
right-click,
Yeah,
flatten it.
exactly. Just treat them all kind of within the same data set pool. Okay, so where do you think these points are going into? The points, right? Good. Okay, it seems like I got my surface, I got my points. Why do I still have this orange box? Now you have to actually determine the quality or characteristics of your flow lines. You have this res one, that's essentially the resolution of your points. So you can think of, if you think of a curve like this, it's probably like a bunch of points that are making a sum. This creates a very high resolution curve. If I did something like this, where it's probably just made of points here, that's a much lower resolution curve. So that's what you're ultimately determining is how many segments or what the distance is of these points. And then the next tab is how many segments am I going to have? So the first one determines the resolution of your curve. And then the second part is how long is that curve? So how many segments am I going to have? So we want our resolution to be fairly low. Like, let's try 5 for now, just because I don't want to overwhelm it. And now we need a calculation. So let's try something like 50.
What is that? What is the calculation?
So the calculation, so you have the resolution is essentially saying every 5 units, or in this case, whatever units you are in Rhino is what units you use in Grasshopper. So 5 means 5-foot segments, and then there's 50 segments making up each curve that are 5 feet long.
I see. So it's kind of the length of the line.
So like if they're 5-foot segments and there's 50 segments, that means they're roughly 250 feet long.
Okay. So that's why some of them are just going off the edge of the...
Exactly. Like there's some kind of weird things, like I don't know what that bad boy is doing, but that's kind of weird. So there might be some issues, so you have to kind of play around with it. Depending on the resolution is going to determine how well it follows these. So you can see even 250 feet doesn't go a whole long. So I can increase my calculation to start to see where those flow lines go. So if I were to just highlight this, and we can turn off this surface point. Maybe even turn off our contours for now so we get a better idea of what that looks like. If we want these to be more detailed, we can obviously increase the resolution, but then those segments are going to get shorter. But you can see, like, if you start to get really detailed, sometimes like the curve doesn't know what to do because it's like, do I go this way? Do I go that way? Like, it's such a high resolution that it's like, I could almost go 100 or 360 degrees if it's flat, right? Like, it just doesn't know how to compute that. But if you keep it somewhat within a mid-range, it knows that it's going to jump whatever that distance is, so like 5 feet. So it's like it gives a little bit better determination. Think of this flow component as like measuring the points of least resistance, right? So if it's calculating like infinite possibilities and it's saying like, okay, in 5 feet, I'm starting to go up in this direction, but if I go this way, I'm going down. That's what I want to do. Like it's always trying to calculate that downward direction.
So where the line's going all squiggly like that, it's kind of an indication of where it's flatter.
That's a good way to do it. And if you look at it, it's reading pretty flat in that area.
So that might be like an area where you have a stream flow spreading out into a sheet flow, and have more potential for infiltration.
Exactly.
Because the water's not moving as fast.
So you could almost start to think of this if I were, like, I'll kind of cover it. You can even start to write a script or an operation that says, okay, like when I have a lot of kind of curving curves, there's probably going to be a lot of points making up those. And so it's like where you have a huge collection of points that could start to inform where there's standing or pooling water. I haven't investigated that, but now I am when I go home or go back to my hotel tonight because I nerd out like that. I've had like,
That's why we workshop.
I know, I've had my coordinator say like, Phil, like I saw that you were online last night. Were you like putting together another script? And I'd just like sheepishly be like, no, I really was. I don't know why. Anyways. Yeah.
Can you fix it?
Sure. So, I don't know why it's doing.
When you say doesn't make it.
Yeah. So when I get stuff like that, like there's some like it's just like any kind of computer program, you're going to run into issues. My first instinct is, okay, let me just change the density of my points. If I just do 21, is that going to solve it? Nope.
Is that the point that you had drawn earlier?
No, it's, I guess that's where it's starting, right? So there's something in that surface that it says like, this is some karst topography. I'm just going to plumb it down. Like making a beeline for that area. Yeah, like
I think it's where we remove those points because there was water there.
Yeah, I can't answer this one. I rarely see that.
If you baked it, you delete that.
Yeah, absolutely. So just like the other things, if that's just like really grinding your gears, and you're like, I do not want that. In the grand scheme of it, nobody's going to notice if I have a missing line. So I can just turn that off, bake it. Because it's like, that looks weird at an angle, so problem solved. Nobody notices. Well, maybe now Val's going to be on the lookout for a missing point and curve, so.
Are we analyzing everybody's?
I mean, I don't even know where that curve is like originating from nothing. Like there's no point that it's actually attached to.
Weird.
That's what's real. Yeah, you get some weird things sometimes. Okay, so let's undo that bake just so we can kind of continue to play around with this. Okay, so we still just got that weird anomaly. So like I said, this gives you a pretty clear idea of how you can run that script. I mean, you can almost easily identify where one of those ridge lines are. It's like, here's where the water is starting to pool into this contour, into that pond. So I think it's actually responding pretty accurately to what the terrain's actually doing. A lot of those squiggly lines are in that pool or that pond over there. So that seems right. And then the rest are ridge kind of going over there. There's a little depression right there. I don't know if that was another pond, but for the most part, you can see, yeah, so like it's definitely flowing into that one. You can see here's a perfect example. Like this is a very clear swale, right? And that drainage line is almost following the peak or the valley of that contour. So I'd say it's pretty accurate. This one is too, so I'd say it's pretty legit. Something to do for now. So just like how we gave color gradients, we can do the same thing for these drainage lines. So let's go ahead and I'm going to double click this, type preview, custom preview. I want to make these drainage lines look blue because it's always good to see water is blue. Oops, that's not the right one. So we want the flow curves. So drag those into there. And I'm going to type, so we haven't done, or I showed you quickly how to do swatches, but if you just double click and type swatch, you'll get a color swatch. One, click on that color, change the hue to something more blue. Drag that into there and turn this off just so that shows up a little bit differently.
I have a question.
Yes.
So you can kind of think of these like smaller tributaries that join up to form bigger drainage waves.
Mm-hmm.
Is it possible to show like level 1 drainage waves combining to be a thicker level 2 drainage wave? Or is that?
That's definitely something you can do.
Does that make sense, the question I'm asking? Like, I think Phil understands, but I'll just drop what I mean.
Yeah. Definitely. Go for it.
Like those join together to make that. And then when those join together, they make something that's
Right.
darker like that, so you can see accumulation happening.
I think so, for sure. That again, like intuitively, it's easy to identify. For how smart Grasshopper is, it's also very stupid. Like it knows what to do in terms of what you tell it to do. It can't read your mind, obviously. You know that like this is one of those examples where you have 2 or 3 tributaries connecting, but in terms of it understanding that logic, it's unfortunately like Johnny Five sometimes. It doesn't understand common sense. So, have any of you guys seen Short Circuit? Do you guys know what the Johnny Five reference is? Oh, that's sad.
I got it, Phil.
Thank you. Okay, so again, none of this has really been an analysis of this landform yet. It's telling us where our contours are. It's telling us where our drainage lines are. One last thing we want to do is actually analyze it for its slope conditions. And then we can start to get into some of those ecological processes like erodibility and vegetation growth. So, I mean, that's kind of cool. You can start to see how it starts to really.
Stopping at some point, so like right where
Yeah,
it is.
definitely. There's some depressions in there.
So that's where it's cool.
Yeah, and like to kind of verify that, you can see there's a pool where it's depressing
I
into.
see, I got it.
Yeah.
This one, I just
Cool.
that or data.
Like this flow script.
Yes. Just somebody made it.
Yeah, like there's ways in which you can create this. They're often called shortest path. It's actually like a computer function that's used for a lot of programs where it understands slope and it determines, like I was saying, like the path of least resistance. That's really what it's doing. Okay, so let's do one more quick operation for this. And there's 2 ways we can visualize this. So this example of a slope conditions, this is actually being created from a mesh. So when it comes to like placing colors on a 3D object, mesh is going to do a really good job of blending colors together. Surfaces need to be kind of parceled out, so it'll look more like Ian McHarg like resolution of being very kind of pixelated. So it could be a good thing or a bad thing. It really kind of depends on how you want to visualize that. So I can show both. You're going to go through the same process to determine it. It's just a slightly different visual, so to speak. So
You'll show us under the surface and then.
yeah, so it's a very kind of similar thing. What's good about this is, yeah, so let's just show both because it's the same thing where we're just calculating vectors, and that shouldn't take that long. So the first thing we're going to do, let's look at it from a surface condition. So a good way to parcel out the surface is I'm going to turn, so you have your surface. it's kind of like, this is another thing that I learned just from my own experience on how to fragment this out. I could like create contours in all those directions to create a grid and use those curves to split the surface, but that's just ridiculous in terms of the processing power needed to do that. So I can use another function to do that. So what I'm going to do is I'm going to take this surface, I'm going to go to math, oddly enough, go to domain, and do divide domain squared. So this is like the very bottom one. So divide domain squared. So it's asking for a domain. In this case, it like all that stuff I told you earlier is a lie according to this, because I can drag my surface into there even though that's asking for a domain. So this is one of those exceptions. With this domain divided, it's similar to how we divided it to points, but now we're dividing it into segments. So I have 10 in the U direction and 10 in the V direction. So it's going to be very large parcels. And I'll show you how those change. Let's do 15, but drag this to 10 just so you see what this is, actually doing. And it's going to definitely extend beyond these boundaries, but I don't think it's a huge issue just because it understands that this surface has been trimmed away from its original conception. And so it actually still reads those points. If I were to click this on, you could see it's still got all those points from that. So that's kind of good. So if you ever need to use that original one, you can do that, but you don't actually delete those points that make up the surface. That's just more or less the outcome from it. So just be aware that it's still going to acknowledge those parts. So the next thing you have to do is, again, we're creating a surface. So we're going to go to our surface tab. We're going to go to utility. And now we're going to do ISO trim. So utility, ISO trim. Again, like I only learned this from looking at the scripts. I would have never guessed this any other way. It's asking for my base surface. So again, that's why I'm dragging this one into here. And now you'll see it's asking for a domain. That's what this is doing. So I'm going to drag that into there. And now you can see it goes back to that original form. But let's hide this for now. But you can see that it's just a bunch of different grids, right? And it even kind of distorts to fit that original component, which is kind of interesting.
Which one did you have?
I hid the original Rhino surface that I had showing up on this. But right now I've got almost everything turned off except for this subsurface or this iso trim and my drainage lines. But like I was saying, because I added this slider to it, I can always enhance that detail. So if I just start to drag this, you see how my resolution starts to increase. So in terms of just retaining this and not having to overwhelm my laptop, I'm just going to leave it at 30. Like that's fairly decent for now. So are we?
What is it going in another direction?
So we're using this. We're essentially going to colorize each one of these parcels based off of its slope percentage. So that's what this is doing, just to kind of clarify for everyone. Like I said, when you're trying to make color associations for surfaces, you have to treat it as modules and not just a fluid surface. That's what meshes are able to do, something like this. Surfaces have to be treated as parcels or modules.
So because a mesh has faces.
Exactly that. Yeah, it's really powerful in its ability to, just like with the point cloud, give points a color association. And like, so if you have a green here and a dark green point here, it's gonna kind of interpolate like that mid-range green in between. But surfaces aren't able to do that.
How do you get the subsurface?
So you got your subsurface. So again, utilities, isotrim. So it's like, it's one of those things where it's like, why does this not match that? You can write to them and complain about that. So, okay, we've got our grid of points. So kind of like what I showed earlier, now we have to determine the direction of each one of these parcels. So in order to do that, we need to actually find the center point of this to do a somewhat of an interpolation. So this applies for most things. If you ever need to find the center point of an object, you might have done this in Rhino where you do like area centroid or something to just find the center point. It's very similar in here. For this, you type area. It gives you obviously the area in square feet of these surfaces, but it also gives you a center point. And this is gonna take a quick second, because now it's essentially creating a center point for each one of those in addition to calculating the area. So now you got all those parcels with a center point. You're going to use this center point to determine the actual angle of these surfaces. So if I stick within this surface part, I can go to analysis. So again, we're still trying to analyze the surface. And the way to do that is that you evaluate that surface. You essentially try to extract that information. So I'm going to select evaluate surface, and I can see what it's asking for. So the surface. So in that case, we're asking for these subsurfaces. And it's also asking for a UV point. This is where it gets a little weird. This is giving me a standalone point. There's no other parameters being associated with it. This is asking for its point UV, which helps us understand the actual normal of these points. So they aren't technically just freestanding points. They technically are orientated to whatever that surface is. And so that's why we have to do one extra step for that. So in order to find that UV point, we stay within the analysis component and say surface closest point. You'll see in this that it is extracting a UV point, and that's what we need. So again, you have your point that you're looking for. So that's your centroid point or your center point of these. And it's also asking for that surface, so our subsurface. So let's turn this off. And so now you'll be able to take this. We really don't need it turned on, so I'll just turn that off as well. Now I'm going to drag my UV into here. And this kind of helps you visualize it because you can see all these planes that are orientating flush with those surfaces. So they're no longer being understood as a single point, but now they've got those new parameters to it. And this is the good part because now you can see that it has a normal direction or a vector in which these are pointing to. A good way to always verify this, because sometimes surfaces get read in the wrong direction. So this isn't part of what you have to do, but it's just kind of a visual to make sure it's working. If you go to curve and do line SDL, kind of like what we did before, I'm going to use the start point. So that's the point from this. And then I want to know like, okay, make a point direction based off of these vectors. It's going to look a little like little hairs growing out of this, but I can see that they are pointing in the correct direction. They aren't pointing downward. I don't think they might be actually. Let's try and make these a little bit longer just so we can tell. Oh, so you can see they actually are pointing in the downward direction. So this is really important. This is why we do this, because even though we felt like it came in the right direction, it's still being read in the opposite direction, which is weird. I can't tell you why that happens, but it just does sometimes. So it's really not that big of a deal. We can just simply reverse that vector direction. So again, we're trying to change the vector or edit that. So I'm going to go to my vector tab, go to vector, and choose reverse. So I'll drag that normal vector again. You're looking for that same icon. Now they're pointing into the right direction. So it's real simple to do that. You can now keep this reverse component there, but you can delete this because this is all we need. Now what we want to do is compare the angle of these surfaces with a vertical direction to find that angle of measurement, which tells us slope percentage. So what I'm going to do now is stay within this tab, do vector, angle. I'm asking to measure two angles, so I have angle A, angle B. So this one from my surface is angle A. And so what's angle B going to be? Up, right, so our Z axis. So I'm going to double click here, type Z, select unit Z, and now I can drag that onto there. So now I'm getting my favorite, angles and radians, because I know what that means perfectly off the top of my head. Have you ever come into situations where you've had to analyze a surface for its radian, its slope and radians? Like I have no idea when I'd ever come across that.
What does that mean?
It's another kind of mathematical unit for angles. Like I said, I don't know any of the application to it. Is it astronomy? Okay. So if you were to import a point cloud of the stars and angle it, I guess.
New challenge.
Yeah, right. Okay. So I'm gonna convert these angles into slope percentage because that's something we're a little bit more familiar with. You could also do it in degrees. That's really simple. If you go to math, trig, and do the degrees component, so you can see when I hover over it, convert an angle specified in radians to degrees. So if you ever need to do that, that's where you can go to figure that out. But we need to convert this to slope percentage. And the formula to convert radians, and this is like another thing that kind of tripped me up when I first learned it, is that in order to convert radians to slope percentage, you find the tangent of the degree multiplied by 100. So you'd think, okay, I need to convert this to degrees and then find the tangent of it. The way this tangent component works is that it's actually looking for radians. It doesn't have to go through that process of converting it to degrees and then multiplying it by 100. That's just the way it worked, and it drove me insane because I kept trying to do that and I was clearly not getting the result. I physically drew a 45-degree angle and it was still telling me it was not 100%. And so that's how I kind of figured out this through trial and error, and realized that it's asking for that actually in radians. So just be aware of that if you lose this function and you're trying to do it, that you don't need to convert it to degrees. So now I'm getting it in slope percentage, but in decimal format. So we want to see it in actual percentage value. So I'm going to multiply this by, so I'm going to go to math. Sorry, I'm starting to kind of breeze through some of these. So math, operations, you got all sorts of different arithmetic. So I'm going to use multiplication. And I don't need a number slider for this case because this value is static. I don't need to change it. So if I double click my canvas and do quote, so shift comma or shift parentheses and do 100, I can input that into there, and now I actually have slope percentage. What I'm going to do now is I'm going to shift this part, because this part is going to stay standard for all of it, for like even for a mesh. So I'm just going to move that over so I can easily shift between a surface and a mesh. So now that I have a slope percentage, now I can do the same thing like before. I can create a color gradient. So we're going to do the same thing where we're going to look at all these values, find their domains or their limits, and create a color association. So we're going to go back over to parameters, gradient. And so again, the first thing it really does need are these parameters or these values. So I'm going to drag that into there. I know it needs that high limit and that low limit. So I'm going to go back over to math, domain, find those bounds. So I can see that the lowest or the flattest part is about 0.05%, and the highest is 77%. So it doesn't even ever get to 100%, which is interesting. It's probably just because it's not a high resolution. But I'm going to now deconstruct that domain. And again, we can use a more kind of common standard of like using this color gradient. So green means flat, red means steep. So we have our low percent and our high percent. And so now we've got for each one of those slopes its own color reference. And just like how we had to do before, we need to actually give these surfaces that color selection. So let's do display, custom preview. So again, we are giving our subsurfaces, this grid of surfaces, a color. Let's turn this guy off. So it's delightful. So the preview is the subsurface. So remember, we're giving these subsurfaces their own color classification based off their slope. So all the way back to the original or start. So look for that isotrim subsurface component. Did you find this one? And then, so we're giving that its color preview. And then we're going to drag this gradient into the shader input, and voila. So like I said, it's a fairly low resolution. I can see, I mean, it is a pretty gradual slope. Like I don't see anything too high except when you start to get into that. So this is kind of the downfall of this approach, is that it's not going to get every kind of single point of that surface. However, if we use it for the mesh, you'll see how much more detailed it becomes. So the only thing we're really changing is going to be around this area. So the rest of this is going to be is going to stay the same for this script, but now we're just going to do it for a mesh. So let's do that. So let's turn this off. So I'm going to take the surface that we've started off at the very beginning, and I'm going to convert it to a mesh. So I may now go to my mesh tab, do mesh brep. I can turn this off. Mesh from brep. So it's this one over here in the utilities. So mesh brep. Oops. So you should have a component that looks like this. I'm going to turn off the surface one because I don't need that overlap. And in order to do this, I'm going to deconstruct this mesh. And what's nice is when I deconstruct this, I retain a lot of the information, so I don't have to go through a lot of this part. So I'm going to take this mesh and drag it near this part that I separated out for doing my calculations. So again, we've got this mesh brep that's coming out of our surface. We've just moved it over here. I'm going to deconstruct it. So analysis, so mesh, analysis, deconstruct mesh. I'm going to drag that in there. So you can see all the points that are making up this mesh. And what's great about it, unlike the other way, is that I've got my vertices, I've got my faces, I've got colors, and I've also got the normal. So it's already giving me right off the bat those directions. I'm going to go ahead and assume that it's doing the same thing as the surface and having these in the wrong direction. So I can always test that by using the vertices, these normals, and I can already... Say that one more time. So we've got our brep or mesh brep, and we've deconstructed it. So mesh, analysis, deconstruct mesh. So what's great about that is that gives us our normals. What we want to do now is that's essentially the same thing as right here. So this is giving us our normals. So is this mesh. So all we have to do, we can just copy and paste this because we want to just keep both of them for now. So I'm going to take this part where I have starting at the reverse and the Z to measure the angle. I'm just going to go ahead and copy and paste that and drag that up to this part where I have my mesh and deconstructed mesh. I already saw that these vectors are going in the wrong direction, so that's why I'm going to plug these ones into this reverse. So we've reversed that direction. For this case, I don't need this preview. Say that one more time. Yes. So again, your normal or your vector is what's getting reversed from our deconstructed mesh. And this is where it works a little bit differently. Instead of using a custom preview, we're going to construct this mesh. So we deconstructed it. Now we want to reconstruct it. So I'm going to stick within this mesh tab, choose construct mesh, and I'll see three important components here, or inputs. So I have the vertices. That's where you can just go right to where your deconstructed mesh component is. Drag the V into there. It's asking for faces. There's your faces. Let's turn this one off. And now we've got the last thing, which is colors. Well, we get to use now our color gradient to be part of those colors. So I'm going to drag this over here real quick, and I'll drag this into there. And now you've got a much more fluid looking slope analysis. So you can see that first one we saw, it didn't have a lot of that resolution as this one, where it starts to kind of creates more of those details. And you can almost see it, it almost follows the the bike path or those MX tracks where you can see they're very distinct lines. There's the pond where it gets kind of steep. Yeah.
Phil, did you use the Google Mesh technique on Ryan Train?
Yes, definitely. And that'll have a lot more detail as well.
Like, so you could just go back to the start with that and reference it in.
Yeah. I don't think I have it on this file, but that's where I would just like reference it right here. Is this a good time to take a break? Yeah.
We said
Yeah.
15 minutes.
Yeah.
10 minutes?
So somehow I ended up with all one color.
Okay. I can do a little bit of troubleshooting while we take
Yeah,
that
we're
break.
gonna take a 10-minute break, so if you have a question for Phil or something, yeah, just let us know. But also, let's try to give Phil at least a couple minutes for a break too. Okay.
That works.
How many people have questions?
Okay, so
Okay,
I'll-
not, just this half of the room.
It should be fine.
The people who are just doing something.
The line was, so you D-match.
So I think I have it in
Yeah.
the mesh is connected to.
That's more than
Match.
Deconstruct
So instead of the A, so like all of the
When it's darker, it's darker.
that might just be oh, that's nice too. Yeah, so one of them is not on the surface. So it looks like you have two mesh, D mesh.
I mean, it is.
Just write this so I know.
Let's see. So it's like, I don't think it's too cheap. Yeah. So we need to.
Can you select everything here? Just to make sure the spot. Yeah, so you got your house. And then it was this last one.
Yeah.
It's not if so let's go back to this one, make sure it's right. So let's start with the surface. And it goes into metal. That's fine. I'll do that. Because you didn't use the line. This company mesh, is that from the surface? So then it goes into deep seal, right? And then turns in, goes to our reverse. With the Z unit, and do an angle on that. Z, yeah. So then into the angle, and then on the infinite times 100. into the balance, into constructed into the gradient of the y. Okay, that's into calculus. Okay. And then this is the v. So see that that should be working. I started everything off. And then it's right. Whatever last piece on, this is working. Yeah. So I this so maybe it's not clear object, so maybe go back. Yeah, that's not a number 100. Yeah, this is so delete this.
Oh, this is
Yes. Yes. There, and then put that in a V. Yeah. It's nice. So, and now this, these oh, two. So, no, I think that was one for us. Yeah. There you go. Tangent. You guys are having, well, this, I'm kidding. So,
Oh, man.
so you need this to start and this and so that's my so fast
I'm lost.
so that one
Like, I did not really
okay,
understand
so
the
that
loss of mesh construction, and then construction, and then construction.
it's do this so that's not being grounded. But this is different, so we're having different.
So let's first figure out this one.
No, see, it shouldn't be. I'm not sure. And you're just double check, it comes from circles. The very beginning here, the mesh, and mesh, you click that and follow with me.
Okay. Sure. See, now you want the first house.
So that's correct as far as everything as best as I can. You know what? Okay, we go to this A times B to R. If you try it now, then you can bring the R into the front. Does yours look like this? It's the same sort of. Get the R, so the result yes, your numbers are very different. This is a percentage, so it should be from 1 to 100. Yeah, this should be from 1 to 100. So there's something wrong before the.
Did she do it that?
Yeah, you have the tangent. The tangent comes from angle A into tangent. Okay, so from the beginning, it's the deconstructed mesh, the normal into reverse,
So play
the reverse into the angle. The right thing,
Okay, I think, she's right, just.
see something wrong with
Yeah, that's it.
these numbers.
No.
These numbers are
But just rely on it. Right now.
But the numbers are wrong.
because yeah, you shouldn't have to do it. The result of multiplication should be from everything from 0
Let me
to
check
1
my numbers.
because it's a
I will
percentage.
check mine.
Just
It has to stay a percent.
How do we get that?
Double click and go
So
to
just
like.
That's
It's
25.
it's a panel, yeah, and then you can take any like out there. Instead of automatically like that. Yeah, you can list so are you doing?
Yeah. I'm not.
I was gonna say, is that the multiplier?
I don't think the same because, we have different boundaries this.
Yeah, but the tangent should be between 0 and 1, and then times 100 should be between 0 and 1. Yeah, yours are all between 0 and 1. That part now.
Yeah, the numbers don't exactly be the same as.
Yeah, because we tracked them separately. So they won't be the same, but you still should conform. Maybe we can ask still. Go back a step, so go from the tan. What does the tan do? Yeah. You have one that's huge. Really? Because none of these technically should be above the speed between 0
List of everything that we need for this
What about?
primary, like, preferences, study cells for vegetation, dynamics or vegetation growth dynamics.
Okay.
And I think the primary hand plant needs light, nutrients, and water.
Okay.
So we can do aspect, soil type, which
We can just make it.
just divide it in half and say this is soil type.
Okay.
If we wanted to later, we could go soil map. And water body or drainage body.
So yeah, the drainage way, that'd actually be very useful.
So we already have those two.
And then soil type, we just kind of create our own kind of process.
Yeah, just like your Johnson.
Yeah. I'll,
But there's three.
no worries, okay.
That I think that this
Existing
is,
vegetation.
because proximity of that might either be Genesis or it could be like, they don't want to be near it,
Mm-hmm.
depending on what the plant it is. I don't know if you want to
Gotcha.
get into that. And then shadows, like, is it getting full sun part?
Gotcha. So I mean,
That would
we're,
require there to be like structures on this.
could you almost classify this as the same as like the aspect?
Well, unless there's like structures that are thrown in shade.
Okay, so I could throw in some like hypergraphical buildings.
Right.
That
Yeah.
because you don't, there's plugins for shade. That's a little tricky because you need a plugin to figure out the shadow projection. I don't even know if I have mine installed yet.
Well, maybe we just consider this as like for fields. Not like landscape fields without
Gotcha.
anything in them.
Okay, that works.
And
And then slopes, that's fine. So yeah, that's easy.
oh wait, no, we don't have aspect, we have slope.
Right, but aspect, we're gonna use very similar. Where like you literally take that slope and like project it on the flat plane and see like where it's.
Yeah. So we build something like that and
Mm-hmm.
say that what we're looking for, the person's in one
Mhm.
flyer is or south face.
Yeah,
So we say one different like flat.
yeah.
So we
That would,
and you can draw things like that.
mhm.
Like shady, moist areas with the same other stuff.
Yeah, so we could do, yeah, we can kind of set parameters of like how to determine like plants based off of aspects, based off of moisture, I guess, or water. So I could do proximity to.
It's easier just to do that too. Maybe we just avoid all of that and just do those three. And then you can get more detail.
We could, let's kind of just go down the list, and if we have time, we can go through.
Okay.
So you want to say like, you can sort, or keep it much simpler than I showed you, or like you can just divide into, I guess there's 4 aspects. Or maybe we can just like, we can show how you can just isolate one of those parameters, and then how you can use a scroll from one to the other.
So that's fine.
Right. Okay. And then, actually, like the soil types would be easy because I can show like it's a lot like with vegetation, or you want to kind of you could get the actual soil profiles from a website, like the soil survey, but like in a space like this where it's been so compacted, like you would have to like go out in the field outside. So we can draw like just records like this is soil type A, this is soil type B. That's how you can use these determine. What would you want to determine from the nutrients?
Yeah, because I know virtual
Because that's like as simple as just saying like, if we were to lay out a random, like this grid of points, it's as simple as just saying like, these points are in the soil curve, these points are outside. Is that what you think would be just?
So like, we had, these 3 things loaded, would it be like, essentially flexible? And like, starting some tweezing slopes and sort of like be close to water. And it would accommodate those 3 things come together.
Yeah. It might be, are you go to
Yes.
Okay.
So like the easiest way is to determine which soil classification you want to do. So start off with this one, so we'll just divide into 2 categories.
Okay.
Then we'll determine, then we'll isolate what's only select ones that are the slope.
Yes.
And then we'll see, so you start to look at filter that stuff out. So it's like, okay, now we're picking ones that are on the slope. So then you will just kind of aggregate points. Okay, let's see which ones. And we can determine like proximity to
Like 3 feet.
Nice.
Yeah.
Okay.
Okay. Do you want to explain the spaghetti sauce?
Yeah, after getting those.
Okay.
Yes.
You guys can get it done.
That's good though. You need to know. Let me say this. Wait for it to say successful.
Okay.
By the way, I wanted to let you know I have the dates in front of me.
Nice.
And names of data. It's, I can tell you where it is. Check.
Okay, perfect. Thank you. I'm just gonna. This kind of looks like spaghetti sauce.
It does look like spaghetti sauce.
Yeah. I'm just looking at this for our final part of, so this is what we're going to be creating now. Just kidding.
It is about to get more complicated though.
It's about to get real.
Can it get slower as well?
So, okay.
We got-
It's more complicated than it
So what
Sure.
time is it? 3:20?
I think, so you might just want to follow along to this point, take notes, take it all in. So far what you've been doing is a lot of the inventory parts, right? Where are the drainage rates? What is the or what is the slope? Now what we want to do is show you how you can start to use Grasshopper as a true analysis tool. So it is going to get a lot more complicated. And just for the sake of time, so we can have some discussion at the end of the day, Phil's recording this, so you'll have access to it.
Ooh, I
You
should
go
probably
back
stop
later at
this.
your own pace. And it will be probably